Well, hello there, boys and ghouls. It's your old pal, Lucid Stew again.
And we have hit a milestone with Fear the Dark, so it's time for another dev diary. Progress is continuing very slowly on the Dreams version, but we have made some strides with the Unity version for our game design class, so we're going to take a look at that. We now have a playable slice consisting of a single level and the most basic gameplay without any real balancing or enhancing. The premise is functional. We have sight, sound, and coding in action, and the player can win or lose the game, so we now have a solid starting point. So let's take a look at what's been done so far. The objective of the game is to stay in light areas to both minimize fuel burn from your lantern and ultimately retain sanity. You can see those two metrics in the UI bars. In order to accomplish that, there are things the player must do and obstacles they must overcome. One thing the player can do is flip light switches to activate lights. There isn't much to that in this level, as it's meant to be introductory for mechanics. Later stages will involve switch puzzles, challenging layout, and possibly expanded gameplay like light and switch repair or interactable environmental obstacles. We also have some doors to open. Currently those are opened by holding a button, but in later iterations those will open with keys, which will present us with opportunities to expand our light puzzle challenges and possibly expand into other puzzle challenges as well. As this is an introductory level and we want to ramp up difficulty, we have also included red emergency light beacons, which give the player a visual cue for where they should be heading. As difficulty ramps up, these will be less frequent and perhaps limited to clues for particularly sticky parts of puzzles. The player retains sanity by staying in light areas or by having lantern fuel in a dark area. There will be sections of various levels that will be intentionally left dark, so fuel management is important. The player will also occasionally encounter lanterns in the environment to help keep fuel in the lantern at key points. The player completes a level by tossing fuel from a lantern into a boiler, which powers the elevator door on that level. Because completion of the level is dependent on retention of a resource, we are being careful about difficulty and also considering alternatives like placing a lantern next to the boiler. In this next room, we first introduce the concept of branching paths, and this will be expanded on greatly in later levels as choices are incorporated into difficulty, puzzles, and gameplay. You can see me rushing a bit here to get to the boiler before my lantern fuel runs out. So we do want to create tension, but at the same time, if I don't reach it in time, I can't complete the level. Repeating a deterministic level like this is not a lot of fun, so that leaves us with some things to figure out. The player jumps into the elevator and activates it, and of course that brings you down to the next more difficult level. We are currently in the process of rectifying minor problems with the current setup, iterating what has been done already to improve it, and also building more levels. Preliminarily, we have 6 levels planned by the end of the semester, but we're running at a pretty good pace so far, so who knows how long the game will be by December. This video is for anyone interested, but most people subbed to this channel are paying attention to Dreams, and also one of the purposes of the channel is to show everyone what the transition to pro engines is like, since I'm making that transition in hopes of gaining employment in the games industry. So let's take a look at how something like this is built in Unity. If you've made any games in Dreams, the various approaches should be familiar. You're simply approaching them in a slightly different way while managing a different framework. We have lots of different static assets laid out to form the various rooms of the level, and the things within those rooms that won't be interacted with. We're not designing this to be created dynamically, so we can put everything in by hand, and that's fine since we're not using a lot of resources. This should be familiar to most people building with Dreams. Also, while I'm pointing out similarities in the Unity framework, we're working in a scene. And when this level finishes, a different scene loads. So again, very similar concepts, just implemented differently. The way we have it set up, the interactable stuff has a script attached to it, and this may seem like a foreign idea to Dreams users, but functionally it's exactly the same as Surface snapping a microchip to an object and then dropping a bunch of gadgets in it to tell the object what to do. We'll take a look at some logic later, and you'll see the syntax of that is quite different, and we'll be working with capabilities Dreams doesn't natively support, like different variable types and functions. We are working in 2D, and Unity can do a lot with 2D that Dreams can't, because Dreams can only do true 2D in the UI layer. And everything you see here is laid out in the scene space using a grid, different 2D layers, and an orthographic camera. Orthographic cameras ignore perspective, and Dreams only has perspective cameras. On top of that, Unity has a lot of tools for working this way, and since Dreams doesn't even have an orthographic camera, it really has no tools for working this way. In addition to lack of online multiplayer, this is probably Dreams' biggest shortcoming. So one thing that Unity will let you do is pick a grid layer, pick a palette of sprites, and then you can just paint on that layer with sprites. Once you have all the sprites you need for a scene, you can build the static part of scenes very quickly this way. It doesn't work quite as simply as smearing stuff around, but once you have a layer set up that works, you know where to put what, and it's fast. It took me a while to build the layout for this first level, but I'm pretty sure I'll do the next in less than an hour. And Sprite Palettes allow you to keep things organized so you always know where the sprites that you need next are going to be. Some things that Dreams mostly does for you that Unity does not is player controls and animation. So in this sequence here, just to get the character to move, Cole had to write a script. Without that script, nothing happens. You might be able to get a character from the Unity store that you can drop in a scene and use, but I imagine you'd have to pay for it. And since we opted to have a custom character, that meant I had to come up with the design and pose, and then draw every frame necessary to animate it. Then I had to come up with animation sequences to figure out how to make it look like it was doing what I wanted it to do, and then I needed to figure out the timing for those sequences so they ran smoothly. This is our first iteration of the character. It requires 34 sprites, 10 animation sequences, and the only thing the character can do right now is idle and walk. I'm currently working on the second iteration with the same capabilities, which will just about double the sprite count so we can animate things more smoothly. By comparison, to get Dreams to do roughly the same thing, you drop a character with base logic in a scene and move some sliders. So that's one reason Dreams can be a lot easier to get something operable set up with. Here we're looking at the player character in the inspector and looking at its various components. One component is a script that controls various things that the character does, so let's take a look at that in Visual Studio. Here's the code in glorious C#. Some things that you're going to see here that are common in programming languages that you won't see in Dreams are different variable types, variable declaration and initialization, and functions. Dreams has variables, so the concept of a variable should not be elusive if you have only used Dreams, but Dreams only allows variables to be numbers. A couple of things we can easily do here that Dreams either can't do or can't do easily are string and object variables, as well as arrays and other ordered container types. You're also seeing a lot of functions here, and functions are possible in Dreams, but they're not natively supported. Functions allow you to do two things. Firstly, they allow you to define a block of code and then reference it. This allows you to run the code in the function at various places in your broader code, but you only have to type it in once when you define it. Secondly, it allows you to establish a scope for that code block to operate in that other code can't touch unless you explicitly allow it. So in that respect, logic is different, and if you want to do this type of scripting, some familiarity with how high-level programming systems work is very helpful. Something that might seem a little more familiar is animation, and that is because pretty much every time-based animation system operates with something akin to a timeline. On screen we have a folder with a bunch of animators and animations. The animations are timelines, and they work the same way. You drop stuff in there and then it plays in sequence. With Unity, the animators serve as state machines that determine when certain animations should play. Earlier I mentioned our character has 9 animations. Each one has a corresponding state. So when the character is meant to be walking to the left with a lantern equipped, the walking left with lantern state is active and the walking left with lantern animation is played. And last but not least, let's talk about sound. Sound is pretty similar in that you have a bunch of recorded sounds and you have to set everything up so the sounds play when you want them to. Unfortunately, it's not that simple as sound triggering happens in code. In that respect, Unity is a little behind the curve in not having a sound event system that would work similar to animators. Overall, it doesn't operate much differently than Dreams, but Dreams just needs a wire hooked up in a playback type ticked. Unity wants information in scripts going into specific functions a specific way in order to work. So I hope that gives you some more insight into our project and also what a transition from Dreams to Unity looks like. Plenty more videos to come when school allows. I'm planning to tackle All Hallows Dreams next weekend, so keep an eye out for that. But that's all for now.
Until next time, kiddies, pleasant screams.